This is the third form 2019 Trinity exam calculator paper. Question 1. So we're told that y is directly proportional to x. We're then told about a fact relating x and y, and we've been asked to find the value of y when x equals 6. Now this is pretty easy and can be done by common sense, just by proportion. But I really want to get third form into the habit of this sort of three-step process so they'll be able to deal with more complicated questions. So step 1 is to get this provisional formula, which I've just put in a dotted rectangle. So because y is directly proportional to x, we can say that y equals k times x, where k is some constant that we need to find out. Say y had been directly proportional to x squared, we'd have said y equals k times x squared. Now, step 2 is to work out what this unknown constant k is, and we can do that because we've been given this fact here, when x is 4, y is 20. So substituting those into our provisional formula, we get 20 equaling our unknown constant k times 4, so clearly k has got to be 20 divided by 4, which is 5. So we found out what this unknown constant is, k is 5, so we can now have a finalised formula, which is what y equaling 5 times x, rather than k times x, because k is 5. Now that we've got this formula, we can then, step 3, we can use this formula to answer the question. So find the value of y when x is 6, so substitute 6 into the formula, 5 6s are 30. Question 2, we've been asked to find the class interval containing the median. So which of these rows contains the median? So median is the middle one. So how many students have we got? Well, if we add up the frequencies, we've got 40 students. Now to work out the middle one, you add 1 to this and halve it. So 40 add 1 is 41. Halve that, we want our 20 and a half students. So what we're saying is because it's an even number, there's 2 in the middle, the 20th and the 21st. So we really need to find where the 20th, 21st student lies. So adding up the frequencies, sort of cumulative frequency, so adding these as we go, we've got 1 student here. When we add on another 2, we've now got to 3 students. When we add on another 8, we've got to 11. Add on another 15, we get to 26. Add on another 12, we get to 38, and so on. So we want our 20th 0.5 student, so they are in part of this 26 here. So our 20th, our middle student, is one of these 15 here. So how long did they take to run the, what were they doing, throw a javelin? How far did they throw a javelin? They threw it this distance, so we just copy out this bit here. So D is greater than 30 and less than and equal to 40. Question 3. So John is training to run in a 100-metre competition. Here are his times. Which would be the most appropriate average to use for John's time? So we've obviously got the mean, median and mode that we can choose from. Now what you've got to pick up here is we've got this extreme value, this outlier. So perhaps he fell over or he twisted his ankle or something, but that outlier so distorts the values that if we were to use the mean, which is our usual average that we choose to use, is going to really distort the mean. So because of this extreme value, we should reject the median. This type of, we should reject the mean. This doesn't really lend itself to the mode, because a mode is really where you've got the same values cropping up lots and lots of times, and clearly all these values are only cropping up once or twice. So really that just leaves us with the median. So the most appropriate average would be the median. So you would line these up from smallest to biggest and take the middle one. Now explain why the other 2 averages do not represent John's time very well. So this is what I was just saying. So the mean will be distorted by the 19.3 extreme value, and because we don't have numbers being repeated frequently, the mode is also not appropriate. Question 4. So we've got to work out the length of AC, this length here. We've got a right angled triangle, we've got sides and angles involved. So the first thing is to pick up that this is trigonometry, SOHCAHTOA. So step 1, we've got to decide which of the 3 ratios to use, sin, cos or tan. And you have to learn this little, these 3 ratios. So however you want to learn them, the acronym I suggest pupils use is Silly Old Hitler Caused Awful Havoc to Our Armies. But you're obviously very welcome to learn it as SOCOTOA. But if you do so, just be very careful with the two silent H's. So the 8.5 is adjacent to the angle. The length OB is our opposite side to the angle, and AC is the hypotenuse of the triangle. And on this occasion, the side that we know is the adjacent side, the 8.5, and we're being asked to work out the hypotenuse. So this question involves adjacent and hypotenuse. So on this occasion, we're going to use the cosine ratio. So cosine the angle, cosine 38 equals, and you've got to get the ratio the right way around. That equals the adjacent divided by the hypotenuse. So the 8.5 divided by the hypotenuse, the length AC. Now just be careful with the algebra now. We need to make AC the subject. So we're going to multiply both sides by AC and then divide by cos 38, giving us AC equaling 8.5 divided by cos 38. Then using our calculator, that gives us 10.786 ... So to three significant figures, that is 10.8. Question 5. So we've got some red beads and some green beads in a bag, and the ratio of red to green is 5 to 9. So red to green is 5 to 9. So how many beads have we got in total? We've got 14 beads in total. So what fraction of the beads are red? Well, that's 5 out of 14. So that's 5/14. Now we're told there is 84 beads in the bag in total. How many of the beads are green? So our total is 84. So put 84 into the total column, and using your calculator, if you do 84 divided by 14, you can see that that is 6 times as many. So to get this row here, we're going to multiply by 6. So 5 6s are 30, 9 6s are 54. So how many green beads have we got? We've got 54 green beads. Now for part C, we're going to add some beads, and we want to end up with having twice as many green beads. So we're starting off with 30 red and 54 green. So we want to get twice as many green, so we want to get twice as many reds as we have of reds. So 2 lots of 30, which is 60. So we're going to have to add 6 green beads. So what beads should you put in the bag? You must explain your answers. So we're going to add 6 greens, and then what do we have? We then have 60 greens and 30 reds. Question 6. Now for part A, I must apologise, I didn't have a compass at home when I did this, so I've had to do this by freehand. So how would you bisect the angle A? Well, step 1, you get your compass and you put your pin here, and you just draw a small little arc, this arc that I've done in purple. Now that's just to establish these 2 points here and here. So taking your compass again, and you can change the length, you can make it a bit bigger if you want. You do 1 arc from here and 1 arc from here, but make sure that your compass width doesn't change between these two. So these 2 arcs are here and here. Now where those arcs cross, so this point here, that's where our line is going to go through. So get out your ruler now and draw it from A through where these 2 arcs cross. And what this final answer, this blue line, does, it bisects the angle. It is halving the angle. Now for part B, we've got to use ruler and compasses to construct the perpendicular from the point P. So what you do here, the quickest way to do this is to put the pin on Q and set the distance of the compass so that it goes through P, and do a big arc. That's what I've done there in green. And then repeat, put the pin over here at R, reduce the length of the compass so it goes through P from R, and draw another arc. Now what we've then got is 2 points where these 2 lines cross. So just with a ruler, lightly go and draw in a line between those 2 points, which I've done in blue. Now our final answer asks us to use ruler and compass to construct the perpendicular from P to the line QR. So really our final answer is just that bit there in purple, which is a perpendicular line from P to the line QR. So it is exactly at 90 degrees going from P, hitting the line QR. Question 7. Now there are a number of different ways of getting to x being 40 degrees. So as long as you have explained each step of your working, as long as you've done that, you get full marks even if you've done it a different way. So the way I've done it, I've kicked off by working out that this angle QCD is 54 degrees, and I've done that by way of the sort of the F angle rule, that what I've just popped in the orange highlighter. So that's the corresponding angles being equal. That angle there is the same as that angle there, because that is a straight line, and that line AB is parallel to the line QC. So that was my first step, starting point. That angle QCD, Q to C to D equals 54 degrees because corresponding angles are equal. Now once I'd done that, I could work out that this angle here, angle ACP, was 50 degrees because angles on a straight line add up to 180 degrees. And then once I had that being 50, X had to be 40 because angles in a triangle total 180 degrees. So you must give 3 different reasons for each of the 3 steps that you did to work out that X equals 40. Question 8. So Ben played 15 games of basketball. Here are the points he scored in each game. Draw a box plot. Now to draw a box plot, we're going to need to know the smallest number, which is 17, the biggest number, which is 28, the median, that's the middle number. So what's the middle number when you got 15? We'll add 1 to 15, that's 16, and halve it, 8. So the 8th one, so 1, 2, 3, 4, 5, 6, 7, 8. So 22 is our median. Now to work, and then we're also going to need the lower quartile and the upper quartile. So looking at the data up to the 20, we need to take the middle value of those. So that's going to be that 18, because that has 3 to the left and 3 to the right. And looking at the data from 23 up to 28, we need to take the middle of those, which is the 26, having 3 to the left of that and 3 to the right of that. So we have the lowest value, lower quartile, median, upper quartile, highest value. And then we draw our box plot to represent that. So the diagram starts at the lowest value, 17. The rectangle commences at the lower quartile, which is 18, and the rectangle finishes at the upper quartile of 26. The median is then just slotted in inside the rectangle at 22, and then the highest value is 28. So do it neater than this, use a ruler please. The height of the diagram does not matter, that is not relevant, it is just the fact that we've got the lines at 17, 18, 22, 26 and 28. Now for part B, we're being asked who is the more consistent between Sam and Ben. Now to measure consistency, we use either the range or the interquartile range. So what I've done over here, I've just set up a little table. So Sam's range is 20, we're told it's 20, and his interquartile range is 12. Now with Ben, his range goes from 28 to 17, which is 11, and his interquartile range goes from 26 to 18, which is 8. Now, either of these, whether you've used range or interquartile range, you can see that Ben is getting the smallest of those. Now that means they're more consistent. You know, the smaller the range, the smaller the difference between your best score and your worst score, or between your lower quartile and upper quartile, the smaller the difference is, the more consistent you are. So Ben is the most consistent because, and you can either have said because his range is smaller, or you could have said because his interquartile range is smaller. You didn't have to mention both, but what you must do, you just must make it clear that you've worked out the values. So if you've done the range, you must make it clear that Sam's range was 20 and Ben's was 11, or if you've done the interquartile range, you've got to make it clear in your answer that Sam's was 12 and Ben's was 8. Question 9. So use the cumulative frequency curve to find an estimate for the median weight. Well, the median weight is going to be the middle weight. So 120 pupils, halving this, we get 60. So we want our 60th person. So we go along on 60, cumulative frequency is 60, hit the curve and take a reading. I think it's about 73. As long as your answer ties in with your graph, you'll be fine. It may be that I'm slightly out, so it may be if you're one up or down from this, you'll be fine. Now the interquartile range, that's what you get when you subtract the person who came quarter of the way up from the person who came 3/4 of the way up. Now 3/4 of 120 is 90, so go along the 90th person and take a reading. I got 80, and 1/4 of 120 is 30, so go along 30, take a reading. I got 65. 80 take away 65 gives you an interquartile range of 15. Again, there will be a little bit of leeway in the answers. Just make sure that you've labelled up your graph exactly like this, so it's really clear how you've used your curve. Question 10. So we've got to complete this table of values for this quadratic curve. Now what I'm really keen for pupils to appreciate here is that this is going to give us a positive parabola, a smiley face, so there is symmetry in the y values, so look for the symmetry. Well look, straight away we can see a -2 here and a -2 here, so put in a little curve underneath. Think of it as like a ripple on a pond. So those two values are the same, so moving inwards, that -5 must relate to that -5. And moving outwards, that 3 must mean that over here we also get a 3. So I've been able to work out the 3 and the -5 purely from the symmetry of the curve. Now of course alternatively I could have substituted the values for x into the equation and worked out the y value, but this is quicker, and also I think you're less likely to make a mistake. So the only one that leaves me that I need to work out is the value for y when x equals 2. So substituting 2 into the curve, I'm going to get 2 squared, take away 4 lots of 2, and then take away another 2. So 2 squared is 4, take away 4 lots of 2, which is taking away 8, then take away another 2, that's 4, take away 8, take away 2, which is -6. So that value is -6. Part B, to drawing the curve, so I just go and plot these points, -1, 3, 0, -2, 1, -5, and so on, and then just do a nice gentle curve. So no points, no straight lines. Now for part C, use your graph to estimate the value of x when y equals -3. So draw in the line y equaling -3, that's here, and then take readings where that line cuts your curve. So it's cutting the curve there at about 0.3 and there at about 3.8. Again, there will be a little bit of leeway in the answers here, but just make it really clear that you've used your graph. So draw all these lines on your graph and take readings, arrowheads, all of this. It just makes it really clear that you've used your graph. Question 11. So for part A, I've got to work out the area of this sector AOB. Now this is a fraction of a circle, so what I'm going to do, I'm going to work out the area as if it was a whole circle, and then just take the appropriate fraction. Now the appropriate fraction is going to be 30 degrees out of a complete turn, out of 360. So that is the fraction, 30 over 360, and then this part is the area of a circle, which is pi r squared. So that's pi times the radius squared. Now the radius is 5, so that's for the pi times the 5 squared. So popping that into my calculator, I get 6.54498 ... So to 3 significant figures, that's 3 digits in total, that is 6.54. Now for part B, I've got to work out the perimeter of sector OAB. That means the length going from O to A to B on that arc, and then B back to O. Now for the first two lengths are easy. O to A and O to B are both radii of 5. So there's my 5 plus my 5. Now the length of the arc AB, that's similar to part A, that's a fraction of the total circumference of the circle. Now what fraction? It's again 30 over 360. And then how do you work out the circumference of a circle? Is pi times the diameter. Now the diameter of this circle would be 10 as you go all the way from B to O to the other side of the circle. So that's why it's pi times 10. So be really clear in your mind that you've doubled the 5 here to get the diameter, but here you've squared the 5 because the area of a circle is pi r squared. So popping that all into my calculator, I get 12.617 dot dot dot. So to 3 significant figures, that's 12.6 centimetres. So question 12, this is quite straightforward. I think the most painful bit here is all the amount of information you've got to read through. But basically we're buying packs of blue paint, and there's 12 in a pack, and white paint, there's 15 in a pack, and we want to get exactly the same number of tubes. So this is a lowest common multiplier problem. So just imagine when you're buying your blues, one pack would be 12 paints, 2 packs would be 24 tubes, 3 packs would be 36, and so on. We're going up in 12s. And with the white ones, we're going up in 15s, because there's 15 tubes in a pack. So one pack would be 15, 2 would be 30, and so on. So when do we first get the same number of tubes? It's when we hit 60 tubes, and that happens when we have 5 packs of blue paint and 4 packs of white paint. Question 13. Now this is quite tricky. You've got to spot that this is a simultaneous equation type of question. So let's let x be the cost of an adult ticket and y be the cost of a child's ticket. So the Singh family, we buy 2 adult tickets, so that's 2 lots of x, and 3 children's tickets, so that's 3 lots of y, and that's going to give us a total cost of £28.20. Whereas with the Peterson family, 3 lots of adult tickets, so 3 times x, plus 5 times y equals £44.75. So that bit in blue, you just needed to spot that this was a simultaneous equation type of question. Now, once you've got that far, you should be all right. So the mechanics of doing this, we need to get the same number of x's or the same number of y's. Now I'm going to choose to line up my x's. So I'm going to triple this first equation and double this second equation, which will mean I have 6x on both occasions. So tripling all 3 of these terms, I get 6x plus 9y equals 8460, and doubling all 3 of these terms, I get 6x plus 10y equals 8950. Now let's call this equation 3 and this equation 4. Now if I go and subtract equation 3 from equation 4 now, my x's will eliminate. 6x take away 6x is nothing. 10y take away 9y is 1y. 89.50 take away 84.60 is 4.90. So y equals £4.90. So my child ticket cost is £4.90. Now to work out the adult ticket cost, I now go and choose one of my original formulae. I've chosen the first one. My 2x plus 3y equals 28.20. And I'm substituting in that I now know that y equals £4.90. So substituting that in, I've got 2x plus 3 lots of 4.90 equals 28.20. So 3 lots of £4.90 taken away from 28.20 is £13.50. So 2x equals £13.50. Halve this, I work out that x, the adult ticket cost, is £6.75.